Hey everyone, this is your friendly neighborhood math teacher, Mr. Bennett, back again with another video lesson. Today we're going to cover 3.3. So we're going to introduce this new vocabulary word called correlation. It's basically the same as our association word that we learned back in 3.1, but it's a little bit more specific in what we're looking at. So for 3.3, our big question for today is what is the correlation R? So R is the variable, the letter that we use for correlation. So just like how mean, we had X bar, we had our little mu symbol. Okay, we have several different symbols for these things, standard deviation, right? We had this. And so the symbol we use for correlation is R. Okay, so that's kind of the first thing. And so what is that correlation value for randomly generated scatter plots? So today we're just going to look at some examples, get you an idea of how to kind of estimate, just based off of looking at graphs, what a correlation is. And so our definition here, what is correlation? Correlation R measures the strength of the linear relationship between two quantitative variables. Okay, so that's what it's doing. It's saying how linear is our data. Okay, and the scale we use for this is from -1 to 1. So we'll kind of talk about what that looks like here in a sec, but that's the idea. Okay, so if we look at, for example, this graph, it doesn't look super linear, right? The dots are kind of scattered a little bit. Like maybe you could say that, okay, this part of it, they all kind of look semi-close to being in a line, but then you have these guys up top that are kind of throwing things off. Okay, so that's the idea, is looking at a data and saying, okay, how close are they to being in a straight line? So if we look over in the top right-hand corner over here on your screen, we have some examples of different graphs and their correlation. So first of all, this top left one, okay, you'll see it just looks like they're completely scattered. They're not really in a line at all. And so you'll notice that R, the correlation, is 0. Okay, so R just means there's no correlation. It's not linear at all. We'd say that that's 0. The next one over, this graph, we're going to say R is negative 0.3. So first of all, the reason it's negative is because those dots in general are going down from left to right. Okay, and so they're going down, but again, right, they're kind of all scattered throughout. They're not really in a straight line. And so for that, it's only going to be 0.3. Okay, it's kind of small. It's not 0 because there is a little bit more of a pattern than the first one. But in this case, it's not really, really big or really, really close to being in a line. So it's pretty small. It's still 0.3, but it's negative because we're going down from left to right. Now, as you go across to the right-hand side, we'll see this one. Now we're going up from left to right. So first of all, you'll notice the correlation is positive. And this one's kind of in a line. And so it's like, this is all kind of grouped together a little bit, but it's not nearly as in a line as the one down below, right? So that's why this one is about 0.5, right? A half. So it's like, it's about halfway to being in a line, right? The graph is, the dots are definitely closer to being together in a line versus, again, our first one. That's what we'll compare it to. But it's still only about halfway there. Okay, so about 0.5. And again, it's positive because we're going up from left to right. And so if we keep going on, I'm going to go down to the bottom left one here. That one, again, they are still fairly close, right? They're getting a little bit closer to being in a line versus this one. See how the top right one, they kind of fanned out a little bit. But the bottom left one, they're a lot closer. But if we notice again, going left to right, it's moving down. And so our correlation is negative. But because it is stronger, it is closer to being in a line, it's now bumped up from 0.5 to 0.7. And as we continue moving through, This one is even closer to being in a line than the previous one. Again, we're going up from left to right, so it's positive now. And that one's almost in a line, right? They're all pretty darn close. So that's 0.9. The closest you can be to getting in a line is 1. Okay, that's why we said over here at the left, right, between -1 and +1. So a 1 means they're all in a straight line, which we don't typically see ones super often, but sometimes we do. And typically the closest we see is something like this last one, right? These are all pretty darn close to being in a straight line. I mean, that's about as close as you're probably ever going to get. So 0.99, but notice it's negative because we're going down from left to right. Okay, so now that we have a kind of general sense of what correlation is, right, what it's talking about, again, the idea of how close is it to being linear, okay? A 0 is not close to linear. A 1 is perfectly linear. Okay, so if it's kind of in between that, where it's like, yeah, it's starting to become a line, then it's a decimal, 0.3, 0.5, 0.7, and so on. Okay, and so between 0 and 1 and negatives just mean it's going down from left to right. Okay, so if it's positive decimal or +1, it's going up from left to right. A negative means it's going down. Okay, so we're still basically working on a 0 to 1 scale or a 0 to -1 scale. But the positive negative just happens to tell us whether or not our graphs are going up, like this one, or whether they're going down, like this one. Okay, so if we look at our first example, number 1, it says we can kind of use those 6 graphs up above to try to estimate, like guess, what we think this correlation would be. So using these 6, which one of those do you guys think that looks closest to? So I'm going to give you a second. Put your guess right here. Okay, which R value do you think it is? So remember, our R values are right there. So I'm going to put the answer I think it is as well in just a second. But take a moment, put your best guess. Which one of these do you think it looks like? And put down the correlation. So in my opinion, I think that this graph, whoops, sorry, screen's bugging out. Our data correlation for number 1, I think that looks probably closest to maybe this one in the top right-hand corner. So I'm going to guess that that's 0.5. Okay, just based off of, again, the 6 examples that we have. Do we think that that's positive or negative? Well, I would say that that's positive because, again, our graph looks like it's going up from left to right. And then do we think that's weak, moderate, strong, or very strong? So again, weak is going to be around 0. Moderate is going to be around 0.5. And strong is really going to be 0.8 and above. Okay, from 0.8, 1. And we're not going to deal with very strong. Okay, we'll just deal with weak, moderate, and strong in this case. And so for this one, because we guessed that it was 0.5, I'm going to guess also, I'm going to say that that's a moderate strength there. And so I would feel pretty confident with that. In this case, we would say that from after the fact, our actual R, as a fun fact, is 0.551. So our original guess was kind of close. Okay. And we'll come back, we'll add some more to that here in a minute. But number 2, okay, again, using our examples up above, what do we think this correlation would be? In my opinion, our graph for number 2 looks pretty close to this bottom right one. So we would say that we're guessing it's negative 0.99. Is that positive or negative? Well, we're going to guess it's negative because it's going down. We're not guessing it's negative. We're saying it's negative because we're smart. We know this. We, as in you and I and our entire class. And weak, moderate, or strong, well, if we're saying it's 0.99, that's really close to 1. So we're going to say that that's strong. Okay, again, we're not going to worry about very strong here. I apologize, I didn't take that off the notes. But we're just going to say strong. Okay, if you want to say very strong because it is really, really close to 1, right, being perfectly linear, you can say that. But for our sake, we're just going to use weak, moderate, and strong. Okay, so I would say that's strong because it's pretty close to being perfectly linear. And then lastly, question 3. Ooh, we got kind of a random scramble of data here. If I scroll back up, I'd probably say it maybe looks closest to this one. They do kind of look like they're randomly scattered, so I'm going to zoom out here so you can see that. Yeah, I mean, you can argue with that, but I think that is probably our closest bet. So let's go with that. So we're going to guess that R is 0. Is it positive or negative? Obviously, right, 0 is not positive or negative, but if we look at our graph in general, as we go to the right, remember we're going from left to right, is our data really going up, or does it look like it's going down? And in this case, it's kind of tricky to see, but here's how we're going to think about this. I'm going to kind of group these together and group these together, right? And there's a couple outside. But in general, our left numbers were higher and our right numbers were lower. And so it looks more negative. And again, that's a little tricky to see with a graph like this. It's not very negative, right? We're assuming our correlation is 0, right? So it's got to be around 0, and we're thinking it's probably going to be a very small negative number, if that. Okay, but that's kind of how we're going to say negative in this case. And weak, moderate, and strong, again, it's close to 0. That's got to be weak. Okay, that's not very linear at all. So for number 2, I forgot to go back and put this, but for number 2, the actual R is negative 0.994. So again, we were close using our example graphs. And for number 2, right, again, why is this strong? Because R, our correlation, is close to positive 1 or negative 1. Okay, in this case, it's close to negative 1. But that's what we're looking at here. Okay, the closer we get to a 1, either positive 1 or negative 1, the stronger it gets. The closer we are to 0, the weaker it gets. So for example, 3, we're weak because R is close to 0. And how close? Well, in this case, the actual R is negative 0.274. So we were a little bit off, but not terribly, because again, that's kind of tricky, and we're just doing this off of looks and not actually calculating anything in a calculator or something like that. But that's okay. Okay, that's just kind of the goal of this, is to kind of just get you used to determining correlations and seeing the correlation in the graph. Okay. Part 4, don't worry about this yet. I guess you can click the link if you're really curious, but we will do that in class together. So don't worry about that yet. That's just a fun little kind of game to guess correlations. So if you want some practice, you're more than welcome to click on that and go explore. But I'm going to move into the wrap-up part of this. So first of all, our first learning target number 1, estimate the correlation between two quantitative variables from a scatter plot. So learning target number 1 is about estimating correlation. I'm going to rewrite that. Sorry about that. Correlation. And so first of all, we're going to simply define what is correlation. So again, correlation is the letter R. And it measures the strength of the linear relationship between two variables. And so correlation is on, you can think of it as kind of on a scale here, where the lowest it can be, theoretically, is -1. We've got 0 in the middle, and +1 on the right-hand side. I'm going to move 0 here because that's going to bother me that that's not closer to being in the middle. There we go. So we have -1, 0, and +1. And so along the way, we actually have some other kind of important markers here. So we'll have 0.5, and then 0.8. And this would be in both directions. So again, -0.5 and -0.8. So what do these mean? Well, again, anything close to 0 means there is no correlation. Oops. Sorry. No correlation. If our value is in between 0 and 0.5 on either side, we'd say that that's weak. If our value is from 0.5 to that 0.8, again on either side, so whether it's positive or negative, doesn't matter, we would say that those are the moderate areas. And then from 0.8 all the way to -1 and to +1 is our strong. I'm going to see if I can't move that all into the box. Ooh, how about that? Nice. Okay, so from 0 to 0.5, that kind of again, really low numbers is weak. Again, if we get to 0, we have no correlation. From 0.5 to that 0.8 range is our moderate. And finally, 0.8 to 1 on both sides is your strong. Okay, so the closer you get to 1, the stronger it is. Now, how do we interpret R? So this is basically, what does R actually mean for our problem, for our scenario? So when we want to interpret R, here's kind of a sentence frame you can use. The correlation R equals blank, right, whatever your R is, indicates the linear relationship of, whoops. Forgive me, I know, I'm sorry, I messed up. The linear relationship between and our two things are the x variable, right, our explanatory variable, and the y variable, or our response variable. So it's the relationship between the x variable and the y variable, whatever they are for our problem. So it indicates that the linear relationship between those two things is, and then we give a strength, so weak, moderate, or strong, and a direction. Which is positive or negative. Okay, so and I'm going to show you an example of using that sentence frame here in a sec, but that's basically what it is. The correlation R equals whatever, R equals 0.3 indicates the linear relationship between our two variables, right, kind of like our context, is weak and positive. Okay, is our strength and direction. Okay, so I'll show you an example of that in just a second. But our last learning target is to remember, okay, that correlation is very similar to association. They're not technically the same, but they're really, really close. Okay, and that is that correlation does not equal causation. Okay, so just because this data is really linear, there's a very clear connection, a very clear relationship between these two things. That does not mean that one caused the other. And we looked at that a little bit the other day in class. I gave you guys some kind of funny examples of that. I think there was one with, Nicolas Cage movies and people dying in their swimming pool. Okay, obviously there's not a causation there. Okay, Nicolas Cage being in movies is not causing people to die in their swimming pools. You can disagree as a joke, but we all know that that's actually true. Okay, but that's the idea. Okay, is just because those graphs show that the data has a strong linear relationship doesn't mean that they're actually still caused by each other. Okay, so an example of that phrase, so let's go back up to our number 1 here. And so we're just going to kind of insert our statement here. So we're going to say the correlation R equals, and I'm going to use the actual one, so 0.551. I don't like those 5s. 551 indicates the linear relationship between, and then what is our x and y variable data? Oh no, we don't have any. Okay, well, we're just going to say that. X variable and y variable. Between x and y, because that's all our variables are. So the relationship between, the linear relationship between x and y is our strength, which is moderate, and positive. And there is our interpretation. Okay, what does that number, what does that R number actually mean? So it indicates that the linear relationship is moderate, so it's kind of linear, but not super linear. And it is positive, it is going in the up direction. Okay, so if you want to stick around, I'm going to kind of quickly go through this lesson app question. So I would suggest you kind of listen to that. But if you want to, if you feel like you're okay with this and you want to stop this and go work on your exercises, that's fine. I won't be offended, I promise. I might be a little heartbroken and sad, but it's okay. I forgive you guys. So either way, this lesson app 3.3, if I eat more chocolate, will I win a Nobel Prize? So it says most people love chocolate for its great taste, but does it also make you smarter? A scatter plot like this one recently appeared in the New England Journal of Medicine. Each point on the scatter plot represents a country. The explanatory variable is the chocolate consumption per resident. The response variable is the number of Nobel Prizes per 10 million residents of that country. So question 1 says, interpret the correlation of R equaling 0.791. So using our sentence frame here, I guess I don't need to use quotations for this because we're just writing a sentence. The correlation of R equals 0.791 indicates the linear relationship between, and I'm going to rewrite that E, sorry. Oh, it's the whole thing. Between our X variable, so chocolate consumption, chocolate consumption, oh my gosh, I cannot spell tonight. Consumption per resident. And I'm adding that in because if I look here, I mean, kilograms per year per resident, it's kind of a weird unit of measurement. But if I look up in the text here, it tells me the variable is chocolate consumption per resident. So we're going to use that. And then it says our response variable, so we're going to say and the number of Nobel Prizes per 10 million residents. And again, right, that comes from the next sentence saying the response variable is this. So the correlation of R equals 0.791 indicates the linear relationship between chocolate consumption per resident and the number of Nobel Prizes per 10 million residents is, well, our strength. So 0.791, ooh, that is just outside of our bar. So remember, if we go back up here, 0.791 would be really close to 0.8, so it's not quite. So it is still in the moderate. So we're going to say that it is moderate. And our direction, since it's positive, we can say positive. And that's it. Okay, and I know that feels like a lot, it seems like a lot, but that's only because our variables are long in this case, right? We had some kind of very descriptive variables here that came from our text. So I'm just going to underline those in the corresponding color. Okay, but that's not always the case for every problem. And then question 2 says, if people in the United States started eating more chocolate, can we expect more Nobel Prizes to be awarded to residents of the United States? Explain your reasoning. So do we think that eating more chocolate leads to more Nobel Prizes? Okay, and in this case, probably not. So we're going to say, although there is a moderate positive correlation between consuming chocolate and Nobel Prizes. This does not mean that it causes that outcome. And so in this case, right, there are probably other factors affecting these variables, right? It's probably not chocolate, right? It could be, education level, right? Are there more, people in the United Kingdom and in Norway and in Switzerland, right, that are educated, that have a higher education? Um, there's all kinds of different things, right? It could be income levels, like people that just have money to be able to spend time doing research. All kinds of different things that, we're not going to get into, but it's probably not eating chocolate, right? We're probably pretty safe to assume that eating chocolate does not cause people to win Nobel Prizes. Are they related? According to our data, yeah, they are related. But in this case, it's not we can't determine, we don't have enough to know here that they actually caused it. Okay, so that's correlation. Again, we will look at correlation again throughout kind of the rest of this chapter. That's one of the big things of this chapter. And so obviously we haven't calculated it yet. Like, how do you calculate R? We will look at that in future lessons. This one is just, hey, can you estimate it? Can you look at the graph? Can you use, our graphs, our example graphs up here, the example graphs we kind of talked about? Can you use the visuals to try to estimate your correlation? Okay, so hopefully you feel pretty confident with that at this point. If not, again, it's something we will practice. But again, I'm going to say it. The assignment, guys, that you guys have, the exercises that I assign you to work on are really, really important here. because the more you practice this, especially things like, writing out the sentence frame, okay, when it comes to interpreting R, is really, really important. Okay, because it's only going to get better, it's only going to get easier the more you do it. Okay, because if you're struggling with it, then you can ask questions. Okay, you can ask a buddy, you can come in and ask me. But if you're not practicing those things, you're not identifying where you don't know things. Okay, so please work on those. Please work on them. If you have questions while you're working on them, you can always either ask somebody there in class, or put a star by them or circle them or something, and then ask me the next day. But that's all I have for you guys today. If you have any questions, let me know. Otherwise, hit that like button, smash that subscribe button, ring the bell for notifications, all those fun YouTuber things. I don't know, I'm not a real YouTuber. Maybe I should be, who knows? Maybe that's a new career for me. We'll see. Have a great night, guys. Have a great day, and I will see you guys hopefully tomorrow.